Newton's first principle. Yeah, he was a busy guy. It's the formula he figured out. If you use this formula, you'll find the derivative of a function. What is the derivative of a function? The derivative helps you find different things. It helps you often find rate of change. Rate of change is just slope, right? Fancy way of saying slope. So whenever we find the first derivative, we're finding the slope of the tangent to the graph. What does a tangent mean? Anyone remember? That is tangent, but that's not the tangent I'm talking about. It's where a tangent, where you were first introduced to it, but you're introduced to it younger too, but one of the bigger ones is grade 9 circle geometry. Tangent is just a line or part of a graph that touches in one spot. So in circle geometry, you would have been given a circle, and then you would be given points tangent like this, and then they drew them like, oop, that's not tangent, that's secant. So this is secant, because I just drew it that way. Crosses through twice. And this one is tangent right here, because it touches once. So tangent is basically touches once, right? Secant goes through more than once. So what we're finding whenever we find the first derivative for the most part at the beginning is we're finding the tangent slope to the graph at a certain point. Because any type of graph I give you, I could give you a graph of a quadratic like this, right? There's millions of tangents on this graph. I have to give you a specific point in order to figure out a specific tangent slope. So if I gave you this point, the tangent slope would actually be what? What's the slope of that line? 0. So whenever I have minimums and maximums, my tangent slope is 0, because it would run perfectly straight. But if I gave you this one, this particular point, my tangent slope would be better. I can't draw tangents today, it seems. That crosses through twice. Pretend it magically is crossing through once. That would be a positive slope, right? And then on this side, my tangents would be negative slope, right? So any point on this side would give me a negative slope. Any point on this side would give me a positive slope of a tangent. And my mins and maxes give me horizontal slopes, which is slopes to 0, which will be helpful when we start trying to draw graphs. Okay, so say I give you this function, all right? I'm going to ask you, given the equation, oh, and I should have f prime of x here, sorry. F prime of x equals this. F prime is like it's a little tick. It just means the first derivative. If I want the second derivative, it would be f tick tick. Third derivative, f tick tick tick. Then when they hit 4 and 5 and 6, they stop doing ticks and they just write 4, 5, 6. It's real. Okay. They'd write 1, 1, 1. And then you would be like, oh no, what is this? Is this a third derivative? Well, it would actually look straight. The ticks are at an angle. So through deciphering, looking close and deciphering, you will see all that deciphering. Okay. So to find the second derivative, you'd have to use the equation of the first and then do this again. So in order to find the fourth derivative, you'd actually have to find the first, second, and third to get the fourth. Because you use the first to get the second, second to get the third, third to get the fourth. It's like probably not. But I'm sure Newton did. Yeah. It's the slope of a tangent. So we're going to use the slopes of tangents to be able to draw graphs. Because if we know if the slopes are negative, then the graph is decreasing, right? If the slopes are positive of the tangents, the graph is increasing. And if the slope is 0, we have a min or a max point of change. Okay. So given the equation y equals, now we'll say f of x, sorry, equals x squared plus 3x determine f prime of x. So we are going to use like power rule, quotient rule, chain rule, product rule, all these different rules, implicit differentiation later on to find derivatives. But the way we first started was through Newton. And what you're going to really do is by doing Newton's first principles, you're going to realize that using the other rules isn't so bad. So when you get to those and you're like whining, I just have to remind you, hey, Newton's first principles, and you're like, ah, right, this is good. Yeah, that's the only way you can be forced. You can be asked to do Newton's first principles, or you can be asked, like, and they'll physically show you this equation and ask you to find the derivative using that equation. All right. So in this equation, we have f prime of x, which is what we want. It equals the limit as h approaches 0, which currently is an issue because we have what in the denominator? 0, because we plug it in for h. Yes? The top says f of x plus h. So if I said f of 2, we would take 2 and fill it in for all the x's in f, correct? If I said f of 2x, we'd take 2x and fill it in for all the x's in f, correct? So if I say f of x plus h, we're actually going to take x plus h and fill it in for all the x's in f. So we are going to get, off to the side, I'll write it out so you can see, f of x plus h equals x plus h squared plus 3 times x plus h. Right? So in the numerator here, we would have x plus h squared plus 3 times x plus h. Then minus, what do we have to minus? Right, we have to minus f of x, which we already have. F of x is this. But what do I have to remember to do when I have a binomial or a trinomial or anything behind a minus sign? Yeah. So what was our ultimate goal? I told you that if we couldn't actually do anything to the numerator and the denominator to simplify a limit, that we'd have to use table of values from the left and the right. We agree? But this one actually looks like there's something we could possibly do. And with Newton's first principles, there's always something you can do to cancel off that h. Okay? So let's try and do some math to get there. So we're going to go f prime of x equals the limit as x approaches 0, or sorry, h approaches 0. And the h approaches 0 until when? When are we going to keep writing that? Until when? What did I tell you? Until you can plug it in. The moment you plug it in, the limit as h approaches 0 goes away. Yeah. You can just go equals. Yeah. So here it's going to FOIL. We're not going to write 8x squared plus h squared, correct? Because x plus h squared is x plus h times x plus h. So we're going to get x squared plus xh plus xh, so plus 2xh technically, plus h squared. Is everyone following me on that? I just FOILed the first bracket. Good. And we'll distribute our 3 in, plus 3x plus 3h. And then we distribute our negative sign in, minus x squared minus 3x all over h. What could we do next? Yeah, combine like terms, get rid of ones that are the same. Ultimately, in the end, we need to get an h to go away. We agree? If we need to get an h to go away off the denominator, we need to have an h by itself in the numerator, correct? So we have to be able to take a GCF of h out of every term. The only way we can do that is if every term that's left behind once we've reduced this has h's in it. So at this step, if everything that doesn't have an h doesn't cancel off, you made a mistake. Okay? So we have an x squared. It doesn't have an h, but it cancels off with the negative x squared. We have a 3x. cancels off with a negative 3x, which we're happy because if those didn't go away, we screwed up. Because ultimately, in the end, we have to be left with just terms with h's. So we can take a GCF of h out. So we have the limit as h goes to 0 of 2xh plus h squared plus 3h over h. Can we put any of those terms together in the numerator? No, because none of them are like. Like terms have to have exactly the same variables with the exact same degrees. These do not. But at this step, we can do what now? GCF out an h. Do you see how if we didn't get rid of the other ones that didn't have h's, we'd be in trouble? We wouldn't be able to take that h out. So that's a huge hint to you. If you can't take the h out, you messed up. Yeah. Because of hamburgers. And they're super yummy. That's why they used h. I don't know why, but I really want a hamburger now. No, it's totally true. Okay, limit as h goes to 0, take out an h, 2x plus h plus 3 all over h. The only issue we have here is that h in the denominator, correct? So the moment that h goes away, we can do what? Celebrate and then put in 0. Okay, so the h is gone. And now the limit can go away because we're subbing in, correct? The limit as h approaches 0 is just there to say, hey, we need to fill 0 in for h at some point. So when we do fill 0 in for h at some point, we're done. It goes away. So we have 2x plus 0 plus 3. So in the end, f prime of x equals 2x plus 3. Now, I told you that it's the tangent slope. That the first derivative is the tangent slope. That looks like a line. That actually is the tangent slope. That's a general term tangent slope. That's the tangent slope for every point on the graph of this quadratic. We agree? This is the tangent slope for every point on that quadratic. Because right now I haven't given you a specific point to find me a tangent of yet, have I? So let's look. The quadratic, x squared plus 3x. I'm going to use the point 0, 0. Woo, that's good. So if I wanted to find a point on this, I could go 0 squared plus 3 times 0, and I'm finding f of 0. So f of 0 is 0. So a point on the original graph is 0, 0. We agree? Now, what if I ask you to find the tangent slope at 0, 0? This is the general term tangent slope. We agree? This would be m tan as well. You can write it like this, m tan equals 2x plus 3. That's my general term. Remember, general terms means you did a general term in geometric and arithmetic sequences and series. You'd make a general term, and then I could ask you for the 4th term, 7th term, 8th term, 10th term, and you just fill that in for n, and you get the term. It's really easy. This is the general term tangent slope, right? That's it's just the tangent slope, but because it has a variable in it, it's the general term. Because you want a slope that actually is a number, like 7 or 10 or 4 or 8, right? Or 3/2, or 15 over 2, or something like that. So if I want the specific tangent slope at 0, 0 now, I'd have to plug it into there. So m tan would equal 2 times 0, because my x is 0. My y is 0, but is there any y in this? Wow, I'm having problems today. Is there any y in this specific tangent slope? No, so I don't have to plug it in. If there was a y, I'd plug in 0. So I'm going to go 2 times 0 plus 3, and my m tan is what? Is 3 at 0, 0. So for ease, because we haven't learned how to draw our graphs without our calculator right now, I want you to type the original quadratic into your calculator, and we're going to do a sketch. So you put x squared plus 3x into your calculator, and then we're going to go to our table of values right now, and we're going to steal points off of it. in a, not this unit, but the next unit, we learn how to graph without our calculators using derivatives. So right now, we're just going to sketch these from our calculator. Yeah, quadratic. So that I can show you that the slope at 0, 0 to make it tangent is 3, to prove that it's correct. So we know we have a minimum for this particular graph. And it's at negative 1.5 and negative 2.25. So it's down here. We know we have a point 0, and we know we have another x-intercept at negative 3. So this is a very quick sketch. Is this super accurate because I used 3 points? Like, it's super accurate, right? 3 points, that makes it the most accurate graph on the planet? No, it's the crappiest graph ever. It's the bare minimum of what I could plot in order to actually get 2 arms. Okay, so if you want it to be accurate, this is not the best way. You can pull tons of more values off. Now, if you didn't have your graphing calculator and you didn't have the table of values, remember what you'd have to do in order to graph this? You have to complete the square to get that. Up to this point, that's what you have to do. You have to complete the square to get your minimum. And then you would have to do a table of values of anything on the left and the right and get your y values and plot them. You could factor and get your x-intercepts, all that stuff. We're going to use derivatives later to find it. Yep. You won't have to, because we're going to learn a method using our derivatives. Like I just showed you way before, that if you get a horizontal slope, that's a possible max or min, right? A horizontal tangent slope will get you a possible max or min. That's what we're going to use to get our max and min. Okay, so I'm going to prove that at 0, 0, if I draw a slope of 3 over 1 at 0, 0, I'm going to get a tangent. Let's do that. So I'm going to go from this point, 0, 0, which is what I just used. And I'm going to go up 3, 1, 2, 3 over 1. Remember, yours is going to be better because I just hand drew this, and it's probably not the most accurate. Oh my goodness. That is not good. But look, what happened? Did that line cross more than once? No, once, right? Tangent at 0, 0. So I know I found the correct slope at least, and I can move on. So you can always run a test point. I just chose 0, 0 because it was the quickest. But you could have filled a 1 in for x and got 1 squared plus 3 and used 1 and 4 and found the tangent slope to that, correct? But what is the actual answer to this question? This right here. I just want you to realize that we're actually finding a tangent slope, the general term tangent slope, whenever we're using this formula. Does that make sense? Okay. And the only way you can find specific slopes of like 2, 3, 4, 5, 6, 7, 8, negative a half, any of that, is by taking a point off of the original graph and plugging it in. So they'll give you a specific point and then ask for the tangent slope of that line at that point. Okay? Yeah. When it's asking for the tangent slope and they don't give you a point, this is it, 2x plus 3. The only way I'm going to get a specific number like 7 or 4 or 18 is if they ask me for the tangent slope at the point 7 and 5, or when x is 2. Like they have to give me a specific point in order to get a tangent slope of a number or a fraction, like 3 over 4. Other than that, if they ask you for the tangent slope and they don't give you a specific point, you're literally getting the general term tangent slope that at any point in time I could fill in any point off the graph and get the tangent slope of that point. Just like in grade 11, when they gave you geometric and arithmetic series and sequences and you found the general term, and then after that the teacher said, now find the 11th term or the 10th or the 12th, and you could just fill it in quickly and get the answer. Okay? That's what we're doing. So we're finding the general term of the tangent slope. Okay. So I gave you a quadratic. They're obviously not going to stay that easy because you guys know that. So let's try. Example 2. I'll give you one more quadratic, and then we'll do. I was just going to end with quadratics for today. Okay. Find the slope of the tangent Okay, to the function. Trust me, being on my channel is not going to make you YouTube famous. I can't even speak English today. That would be a much better idea. Okay. Not I think. You know more people watch Mr. Dickey's. Okay. So, this question here specifically asks us to find the slope of the tangent. The only way we know how to find the slope of the tangent at this very moment is using what? Newton's first law, Newton's first principles. Okay? I will call it, sure, we can call it with a law because Austin wants us to. Okay. Then at the end, once we find that, when we use Newton's first principles, we are going to actually get the general term of the tangent. And then they specifically want it at 4. Okay? All right. So we're going to do f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Yeah. That's the actual formula for it. Yeah, that you fill in. So let's fill in what we know. F prime of x equals the limit as h goes to 0. F of x plus h, what does that mean again? X plus h every time there's an x. I'm just going to do it off to the side to prove again what it is. So f of x plus h in this instance, we're going to fill x plus h in for all the x's. So we're going to get x plus h squared minus x plus h minus 12. And that is going to go in for f of x plus h. And then we subtract off f of x. And they gave us f of x, correct? So we just write our f of x, but it's a trinomial, so we have to make sure it's in what? It's a trinomial, so it needs to be in what? Brackets. All over h. What do we do next? Because ultimately our goal is always to do what the whole time right now? Get rid of the, what's our problem? The h. Our problem is the h, so we have to get rid of it. So we're going to expand the numerator and hope that we can get rid of all the terms that don't have h's in them, so we can take out a GCF. So limit as h goes to 0. Remember, x plus h squared is just x plus h times x plus h. Do not fall to the oopsie of x squared plus h squared, which is not correct. You need a middle term. So we're going to get x squared plus xh, so plus 2xh plus h squared minus x minus h minus 12 minus x squared plus x plus 12 all over h. Our next step is to cancel, and everything needs to go the way that doesn't have a what in it? An h. So x squared, negative x squared. Negative x, positive x. Negative 12, positive 12. All the rest of the terms we have left have what in them? An h, which makes us happy because we didn't mess up. So now it equals the limit as h goes to 0 of h squared minus h plus 2xh. They can go in any order. I'm just writing them that way. But they can literally be written in any order and you wouldn't be wrong. What's our next step then? GCF of an h out. H's cancel, and then what can I do in my next step? Put 0 in, and then the limit drops off the moment you put in substitute in the 0. So ultimately, in the end, I have f prime of x equals 2x minus 1. So the first derivative, that's what this means. The first derivative is 2x minus 1. But the first derivative is also the same as saying m tan equals 2x plus 1. Now, a whole bunch of people at the beginning will tell me the tangent slope is 2 because whatever's in front of the x is the tangent. No, that's the general form tangent slope, correct? That is the tangent slope before I plug in anything. Yeah. Yeah, I don't know how I just should change that to a plus. I'm gifted. Okay. So the second derivative, what we will find out is the second derivative helps us find where the maxes and mins are. So the increasing and decreasing max and min. The second derivative will also give us the concavity. So based on the concavity of a graph, you can find out if it's a min or a max, stuff like that. Points of inflection come from the second derivative. Okay. Increasing, decreasing comes from the first derivative, right? Because if our slope was positive, we knew that the graph was increasing, and if our slope was negative, we knew that the graph was decreasing. If our slope is 0, we know the possible max, min, and point of inflection. Okay. Are we done? The question said, find the slope of the tangent. Boom, got it. That's general slope of the tangent. But it wants it to the function x squared where x equals 4. So they want a specific one. They don't want the general term. They want a specific point. Now, some people will say, but I don't know what the y is. Do we need the y in this case? No, because it's only an x. Could we get the y of the point? How could we get the y? Yeah, so this is an original x. It's an x on the original graph. So I would just plug it into the original graph for x, and I'd get my y. Right? Not a big deal. Okay, so let's go down here and let's find the slope at 4. So when x equals 4, m tan equals 2 times 4 minus 1, which is 8 minus 1, which is 7. How could we check this? We could draw our original graph, correct? Find the point at 4 and whatever it is. Go 7 up, 1 over, or go 7 down, 1 left, because you go the complete opposite, and see if it draws a tangent line. If it makes a secant line where it crosses more than once, you oopsed, either in your drawing or in your slope. So that's how you can check it, is by drawing it. Make sense? Okay. Page 150. Numbers 5 and 6. Forewarning you, number 6 is a trinomial, so you'd have to go like x plus h times x plus h times x plus h, FOIL, distribute, all that joy. Okay? Super joyful. And then 27 and 28 is another trinomial. There's only 4 questions, so you can't complain.